Good day to all of you, everyone. I'm Mashiko de la Cruz, and I'm here with my fellow groupmates Elmi Alinsub, Kent Balasi, Abra Bongaling, Bernice Nicole Francisco, Charlie Suzanne Palera, Axel Penaflor, and Alaina Velosa.
Today we are going to introduce and discuss deeply the lesson about differentiation, particularly its history, application in the Mindanao context, fellow word problem with solutions, and tips that encourage you to be more motivated and enlightened in learning thoroughly the concept of differentiation.
In the 19th century, calculus was put on a much more rigorous footing by mathematicians such as Augustin Louis Cauchy, Bernhard Riemann, and Karl Weierstrass. It was also during this period that the differentiation was generalized to Euclidean space and the complex plane, though the origins of the integral calculus are generally regarded as going no farther back than to the ancient Greeks. There is an evidence that the ancient Egyptians may have harbored such knowledge as well. An Indian mathematician, Bhaskara, gave an example of what is now called differential coefficient, and the basic idea of what is now known as Rolle's theorem. Leibniz and Newton are usually designated as inventors of calculus, mainly for their separate discoveries of the fundamental theorem of calculus and work on notation.
There has been a considerable debate about whether Newton or Leibniz were the first to come up with the concept of calculus. The truth, the truth of the matter will likely never be known. Leibniz's great contribution to calculus was his notation. This controversy between Leibniz and Newton was unfortunate in that it divided English-speaking mathematicians from those in Europe for many years, setting back British analysis for a very long time. Newton's terminology and notation were clearly less flexible than that of Leibniz, yet it was retained in British usage until the early 19th century, when the work of Analytical Society successfully saw the introduction of Leibniz notation in Great Britain. It is now thought that Newton had discovered several ideas related to calculus earlier than Leibniz had. However, Leibniz was the first to publish. Today, both Leibniz and Newton are considered to have discovered calculus independently.
The derivative of a variable is defined as a method of calculating the rate of change of a function's output value as it differs from its original value or input. The rate of change concept makes it a valuable asset in many real-life applications. It has a broad range of practical utilities. The uniqueness of this concept is its predictive ability to evaluate the change in quantities.
Some regions in Mindanao, especially regions that are near to the sea, use weather derivatives that can be used in predicting weather conditions so that they will be aware of an incoming typhoon or big rainfalls. Derivatives can be also used in predicting the velocity of objects. They can be used in predicting the path of a typhoon in the next number of hours. It can also be used in big businesses, since handling business has become more mathematical at the present time. It can help you make good decisions regarding possible gains and losses in investments.
Now, let us move on to the different word problems. The delta method. For the first problem, a PAL international plane in Mactan Cebu International Airport is ready to take off in a few hours before heading towards Shenzhen, China. To do that, an air traffic controller prepares the following information, such as the proper distance between the fence and the runway lights, in order to prevent delays or inevitable disasters that may occur. They prepared a derivative function for the pilots before departure, which is y is equals to 5x squared minus 7x plus 2. In that situation, what will be the proper distance between the fence and runway lights? For the first step, use the slope formula of the delta method, which is delta y over delta x is equal to lim of x is to 0, wherein f of x plus delta x subtracted by f of x over delta x. The second step will be applying the formula by substituting its given values for the equation. So, the first expression will be 5 is multiplied by x plus the derivative of x squared. The second would be the negative 7 multiplied by x plus delta x plus 2. And the last expression will be negative 5x squared minus 7x plus 2 divided by delta x. On to the next step, expand the solution of the equation. So, for the first expression, you must expand and simplify the equation 5 times x plus delta x over squared, which results as 5 times x squared plus 2x times delta x plus delta x squared. For the second expression, the expression will be negative 7x minus 7 multiplied by delta x plus 2. For the last expression, the negative sign will be distributed in the parentheses, following the rule of multiplication. Now, the expression would be negative 5x squared plus 7x minus 2. Proceeding the fourth step, we must eliminate the common values that can be seen in the equation. Based on the equation, we can eliminate the values of 5x squared and negative 5x squared, negative 7x and positive 7x, and lastly positive and negative 2 divided by delta x. And next, we must simplify the equation after eliminating the common values. The result will be 10x multiply delta x plus 5 delta x squared minus 7 delta x divided by delta x. After simplifying, we must factor out delta x in the numerator. With that said, the expression of this will be delta x multiplied by 10x plus 5 delta x minus 7 divided by delta x. Additionally, the delta x in the numerator and delta x in the denominator can be crossed out to each other and the value will be 1. Moving on, we must simplify the equation again. The equation will be now 10x plus 5 multiplied by delta x minus 7. After that, we must substitute the value of delta x wherein delta x is equivalent to 0. This results as 10x plus 5 multiplied by 0 minus 7. Applying the multiplication rule, 5 multiplied by 0 will be 0. Here, the final equation will be that the derivative is equal to 10x minus 7. And now, we have solved and answered the question above. Therefore, the proper distance the BaCal international plane should coordinate with is 10x minus 7. That is all. Thank you.
Good day, everyone. I'm Alina Mesha Veloso, and I'll be presenting the algebraic method. For the second problem, during the Philippine election 2022, one of the candidates obtaining a senator provided her SALN in the court. The court was confused because her SALN was too large, so they recounted it. How much was her SALN? This was in the form of the first derivative of f of x is equal to 2x squared minus 6 multiplied by 3x cubed plus 8. From the situation shown, what is the SALN of the candidate mentioned? For the first step, we must use the algebraic product rule formula in order to determine the SALN of the candidate, which is u multiplied by the derivative of v plus v multiplied by the derivative of u. Moving on to the second step, we must solve the equation of f of x is equal to 2x squared minus 6 multiplied by 3x cubed plus 8. And then we must find the derivatives of both expressions. To do that, we must label them first. The value of u is 2x squared minus 6, while the value of v is 3x cubed plus 8. After labeling the values, we can find both of these values' derivatives. The derivative of u is 4x, while the derivative of v is 9x squared. After that, we can now apply the formula above. This would be 2x squared minus 6 multiplied by 9x squared is positive by 4x multiplied by 3x cubed plus 8. We must apply the distributive property in between expressions. Here, the final result will be 18x to the exponent of 4 minus 54x squared plus 12x to the exponent of 4 plus 32x. In the last step, we must simplify and combine like terms. We must use the rule of exponents, thus knowing that the result would be 30x to the power of 4 minus 54x squared plus 32x. And now we have solved and answered the question above. Therefore, as our conclusion, the senator's SALN is 13x to the exponent of 4 minus 34x squared plus 32x. That's all, thank you.
Problem 3. The Philippine Space Agency received a warning from NASA and says that a meteor will likely enter the Earth's orbit, and they estimated that it will hit Southeast Asian countries. A Philippine-based meteorologist was given a task to figure out the estimated days that the meteor will likely enter the orbit. Thus, the meteorologist finds the slope of the line tangent to the curve of y is equal to 3 sin of 4x divided by x, where x is equal to 1.8 to the number of days. For the solution, step 1 of first step, we must identify the variables in the problem highlighted. So, h is equal to 3 sin of 4x and L is equal to x, while the derivative of both labels is that the derivative of h is equal to 12 cos of 4x and the derivative of L is equal to 1. In the next step, as the given variables, we must use the algebraic quotient rule formula, wherein the derivative of h over L is equal to L multiplied by the derivative of h minus h multiplied by the derivative of L divided by L squared. Moving onward, we must substitute the given variables. The result would be x multiplied 12 cos of 4x minus 3 sin of 4x multiplied by 1 divided by x squared. After that, we must simply use the derivative property in each expression. So, the technical equation will be 12x cos of 4x minus 3 sin of 4x divided by x squared. However, the problem has mentioned a given value which is x is equal to 1.8. With that, we must substitute 1.8 to the given equation solved. In other words, the slope of the tangent is equal to 1.8. Furthermore, the equation would be y of 1.8 is equal to 12 multiplied by 1.8 to the cos of 3 and 1.8 minus 3 sin of 4 and 1.8 divided by 1.8 squared. The final answer of the equation would be y of 1.8 is equal to 3.5. And now, we have solved and answered the question above. Therefore, the meteor will likely to enter the Earth's orbit in approximately 3.5 days.
Assume that the amount in grams of a certain mercury substance present at the time t in years is given by the derivative Mt is equal to 700 e to the power of negative 0.34 t. Find the rate of change of the quantity present at the time when t is 7. For the first step, we must apply the formula of derivative exponential functions. Here, we can apply the derivative of e to the power of u is equals to e to the power of u multiplied by u. To the second step, we must substitute the given equation. Here, the derivative of equation a to the t is equal to 700 times t to the power of negative 0.34 t multiplied by negative 0.34. Moving on, we must simplify the equation. This result will be negative 238 e to the power of 0.34 t. As we came across to the final equation of the problem, we must substitute the given variable indicator in order to find the rate of change of the quantity present when t is equal to 7. Afterward, we must simplify the equation again. Here, the derivative of a of 7 is equal to negative 238 to the exponent of negative 0.34 multiplied by 7, whereas the new front equation will be negative 238 to the exponent of negative 2.38. The leading answer would be that when negative 238 is multiplied by the value of e to the exponent of negative 2.38, use a calculator to simplify e to the exponent of negative 2.38. The result will be negative 22.03. And now, we have solved and answered the equation above. Therefore, the derivative change in quantity of the certain nuclear substance after 7 years is negative 22.03.
Before New Year's Day, city officials of Bonifacio Global City or BGC wanted to commemorate the big holiday for the residents of the metropolitan area. The city government decided to plan a huge fiesta celebration in the heart of the modernized city during the night for 3 days. With that initiative, they have a budget of p of x equal to 20x to the power of 4 minus 12x cubed plus 8x squared plus 4x minus 30. A. How much was left in the budget on the first day? Write it in function form. And B. On the last day, how much money was left if x equals 3? Write in Philippine currency. For the first step, we must use the concept of higher derivatives as p of x equal to 20x to the power of 4 minus 12x cubed plus 8x squared plus 4x minus 30. To the next step, we must find the value of each first derivative. Here, we can illustrate that the expressions apply to the concept of constant and power rule. So, the equation that will be inputted is 20 times 4x to the power of 4 minus 1 negative 12 times x, 3x to the power of cube minus 1 positive 8 times 2x squared minus 1 positive 4 times x to the power of 1 minus 1 and negative 30. And here, we simplify the equation, found the answer of the first derivative, and may start to proceed to solve for the second derivative of the problem. The equation would now be 80x cubed negative 12x squared positive 8x and positive 4. Proceeding to the next step, we use the concept again of constant and power rule. Underlying here, the equation would be 80 times 3x cubed minus 1 negative 12 times 2x squared minus 1 positive 8 times x to the power of 1 minus 1 and positive 4. And here, we simplify the equation, found the answer of the second derivative, and may start to proceed to solve for the third derivative of the problem. The equation would now be 240x squared negative 24x and positive 8. Forward, we must use the concept of constant and power rule again. Now, the equation would be 240 times 2x squared minus 1 negative 24 times x to the power of 1 minus 1 and positive 8. And here, we simplify the equation, hence we found the answer for the furthermost and last derivative in the problem initiated. The final equation would be the third derivative of p of x is equal to 480x minus 24. However, we just haven't completely solved the problem. We must substitute the value of x in the determined final equation in order to conclude the total expenditure the government BGC has allocated. After solving the final equation, we must substitute the value of x as it is equal to 3, in which the fiesta celebrated falls and closes on the third day. So, the equation would now be the third derivative of p of x is equal to 480 times 3 minus 24. Next, the third derivative of p of x is equal to 1440 minus 24. And lastly, the third derivative of p of x is equal to 1,416 pesos. And now, we have solved and answered the equation above. Therefore, the budget for the first day would be p of x equal to 80x cubed minus 12x squared plus 8x plus 4, whereas the remaining money that is spent on the event is 1,416 pesos.
As we enter into the dimension of acquiring tips for you, future basic calculus learners in learning differentiation, there are some tips that we want to highlight for your own anticipation. First, don't rely too much on a calculator. Math should be on logical practicality, not relying on technology. You should practice at least the basic concepts of math 2 or more times before proceeding to grasp the further complex concepts like differentiation. Second, comply and comprehend fully your handed assignments. Practicing as much as you can with reliable information such as books, YouTube videos, and many more sources of mediums can help you accomplish and understand efficiently and briefly encapsulate. It provides a clearer picture that simple concepts can be narrowed down and pinpointed in an organized manner by certain strategies from other teachers. Third, find trustworthy people to study with. It is important to take note that people's influence can be a vital aspect of our study environment. When we are centered on accomplishing and gaining information provided to us, peer buddies help and strengthen our core memory and familiarizing the concept tackled and reduces the probability of getting distracted when working with the right people.
Fourth, don't give up. Encouraging phrases and self-motivating quotes helps you persevere and be mentally strong in dealing with overwhelming tasks and assignments. Doing this every day enlightens the mood and reduces the negative thoughts that encircle your mind. Fifth, don't be afraid to ask out that asking for peer evaluation and contributions helps reduce the chances of being stressed out. Knowing your self-worth with others despite being bombarded with negative thoughts and overwhelmed by criticisms helps accomplish your goal. It is important that our failures reflect our chances to become successful, so analogically, it is the same in learning differentiation. When we don't grasp the lesson completely, we can still strive and foster in learning various materials such as videos or with our peers. Lastly, don't stress out due to the designated assignments. In learning, we should be able to relax and take a break when processing different concepts and strategies. It helps us alleviate and organize the train of thought we are trying to solve and pin down the various methods discussed.
And here's our references. As we end our presentation, we would like to thank you for listening to us on our report about differentiation, particularly derivatives. We have done our best to present the different things about the subject derivatives. We have presented its history, real-life applications, and problem sets that show the usage of derivatives in real life. We appreciate for taking the time to listen to us. Being in a group makes studying easier and fun. As the saying by Steve Jobs goes, learn continually. There's always one more thing to learn. Goodbye.